Alright, today students, we are continuing our study of circles with notes 10.3, which is applying properties of chords. We're going to start here with a few of our theorems, and the first one says, in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. Okay, so if you look at the picture, what that means is we have the same circle. We only have one circle, so both of these chords are in the same circle. This arc right here, AB, is congruent to CD, arc CD, if and only if chord AB is going to be congruent to chord CD. And remember, this goes both ways. You can start off with the chords and get the arcs, or you can start off with the arcs to get the chords congruent. Alright, next. If one chord is a perpendicular bisector of another chord, then the first chord is a diameter. Okay, so starting here, we know that right here, if QS is a perpendicular bisector of TR, then we know that QS is a diameter of the circle. Okay, so if this chord right here is not just going to cut this in half, we have to see this perpendicular mark here, which is a right angle mark. So if we see that, then we know that this must go through the center. It must be a diameter. All right, the next one. Now we're going to start off with a diameter. So if a diameter of a circle is perpendicular to a chord, so all we have is this line right here being perpendicular to this one. We don't know that it's cutting it in half. Then the diameter bisects the chord and its arc. Okay, so what this is saying is, since we know that this is a diameter, if EG is a diameter, and we know that EG is perpendicular to DF, then we know that HD must be congruent to HF, and we know that arc GF is going to be congruent to arc GD because it's going to bisect the arc. right, next, again we have in the same circle, or it could be in congruent circles. Two chords are congruent if and only if they are equidistant from the center. Okay, so what we know is I have this chord here. That's going to be AB is congruent to CD, but only if and only if, we have this and this, they are equal to each other because it's equal distance. We have to see this right angle mark too. So that's going to be EF has to equal EG. Not that they're congruent segments, it's that they're equal because it's equidistant. And remember, distance is the perpendicular segment. So must see the right angle mark. Okay, so you must see that right angle mark there. Otherwise, you can't determine whether or not it is equidistant. Okay, next we have some examples. Alright, so remember that it said in the same circle or in congruent circles. And right here they're telling us that in the diagram, circle A is congruent to circle D. So those two are congruent. The other way we can tell that they are congruent is because this radius here and this radius here, they're showing us that those are equal radii. Okay, so since they're congruent circles and since we know that BC is congruent to EF, that tells us that EF, arc EF, is going to be congruent to BC. And that's because of, we have to have this and we have to have this. Because of this and this, we know this. Alright, well, since we know that, then we know that the measure of EF equals the measure of BC. So since EF is 125, we know that that has to equal the measure of BC. There you go, 125 degrees. Make sure you put degrees. Alright, and the next one, next example. It says, use the diagram of circle E to find the length of BD. Tell what theorem you used. Okay, so here we have AC being a diameter because we can see that it's a chord and we see that it goes through the center of the circle. So the theorem that we're going to use is if AC is a diameter, and AC is perpendicular to a chord BD, then we know that BF, sorry, not that. No, don't put segment notation. We know that BF is equal to DF. Alright, so here we know that DF happens to be 6. So we know that both of these have to be 6 All right, but they didn't want that information. They wanted to know what the length of BD was. Well, BD we know is BF plus FD. So BD has to be 6 plus 6, which is 12. And this is the theorem that we used. All right, next. Use the diagram of circle F. If AB equals CD, which equals 12, both of them are equal to 12. You can see it, it's written right here. Find EF. Okay, since these chords are congruent, we know that they are equidistant to the center. So we see these little right angle marks, and we know that they are FG and FE are equal. So since FG equals FE, then we can say that 7x minus 8 is equal to 3x. I'm going to subtract 7x from both sides. I get negative 8 on the left equaling negative 4x on the right. Now I'm going to divide by 4 on both sides, divide by negative 4 on both sides, so I get x equals to 2. Alright, but that's not what they wanted. Remember, they wanted the length of EF. Well, EF is equal to 3x. So EF is equal to 3 times 2, which is 6. Alright, you're going to be doing these 3 check your understanding problems yourself and make sure you bring them in for full credit. And folks, that is it for notes 10-3.